So what we have here is our geothermal install. Many of you guys will install the actual units themselves, but you won't do anything with the loops. And we'll go into discussion about the loops here, as well as the fusing of the different pipings together. But you're just not going to see it in the field as much as you'll be doing more service on these than you ever will install of a geothermal unit. But we'll go through the principles of the install. So there's different classifications of heat pumps, geothermal heat pumps, that is. Open loop, which we're using the groundwater, pumping it out of the ground, running it through the geothermal, and then sending it out into a drain. The next thing we can do is we can coupling a polyethylene pipe together or fuse it together and then have it run underground. And that's considered a direct, it's considered a closed loop system. And then what you're going to be running into is a direct exchange system where we're running the copper pipes in the ground and the refrigerant is running out inside the copper pipes outside. So we'll be running into those three different types of configurations when it comes to our geothermal units. So here's a breakdown of our geothermal unit as we're looking at it. As we can see, the indoor unit has the geothermal source heat pump on the inside, and then our water loops are running out into the ground where they're going to extract heat from the ground or they're going to reject heat into the ground. Okay, as we continue to talk about our geothermals, let's first look at our groundwater heat pump or groundwater geothermal type of system. The use of groundwater is out of a well. The well is dug by somebody else. It's not going to be dug by you, but it could be an existing well as too. And most of these flow rates are going to be about 1.5 gallons to 2 gallons per ton of refrigeration when we look at it. And these wells should be capable of producing that type of flow rate through it. So using groundwater, pumping it out of the well, and then using it in the geothermal, and then dumping it down a drain or into a pond. It's not going to be something that we're going to dump it back into the same well. And you're thinking, why not? Because the EPA won't let us do that. It was the way the old systems were set up, and no longer are we allowed to drop that water back into the well because of contamination, because we brought it out of the ground. Okay, so open loop systems. The well can be existing or new, and the water can be pumped from the well and then dumped down the drain, a pond, or into a stream. Continuing our look at open loop type systems. This is a geothermal unit that we have right here, and the geothermal unit has electric as well. We need a backup heat for our geothermals, just like we do for our heat pumps. Here's our well pump or our pressure tank, and basically what's going to happen is the water is going to flow out into the geothermal and then come back out into the a drain of some sort over there. So out into the geothermal and then back out this way. Now here's your basic well setup. If I was a plumber, I was an HVAC technician, I was an electrician. So you're going to be moving into all sorts of different areas when you're in this field. And trades are good. Knowing the trades is really good to know, because then it makes it more valuable. And you can end up hopping around at different companies and making a tremendous amount of money because of the knowledge that's in your head. Just remember that. Don't try to say, I don't want to learn that because I don't want to do that, but learn it because you will need it later on in life in some aspect of your living. So here is a well. A well is a dedicated geothermal well. There is a submersible pump on the bottom side of it right in here. This pump will grab this water and pump it into a pressure tank. That pressure tank will pressurize so that you're not continuously running the pump, but it will bring it up to about 20 or 30 gallons and then shut off. And then you'll have 20 or 30 gallons of water that you'll be able to use before that pump will start to kick on again. There's a lot of different parts that go into the pump, into the well, and we're talking about pitless adapters, and those are just adapters where we're drilling into the side of the casing. They are watertight so that we don't get any groundwater and contaminating the actual well. And then you have a couple of different pipes there. They're showing you a return pipe, but we're no longer allowed to do that. just another setup of your well system. Oh, look, they gave us another well on the other side. We don't do that anymore, but I mean, just imagine that you're dumping it down the drain or into a pond at that point. But the submersible pump pumps it up into the pressure tank. Pressure tanks goes into the geothermal, and then we have a solenoid or a slow closing valve on the one side that will shut off the water flow when the geothermal is not on for the system itself. Now, I have one of these out in the shop, so make sure you're getting your hands on it so you have a good understanding of what's going on. Not the well, a geothermal that's a pump and dump, pumping city water through it instead of well water. Now we have static water level and pump water level, and then the drawdown is basically what it is from the static to the pump water level. That's the drawdown amount, and that drawdown amount goes below the actual submersible pump. Then we're going to be sucking air in. You're going to have all kinds of problems. So we basically will know by the well. The well driller will tell us how many gallons per minute that is capable from this well, and then we'll be able to determine if we want to use this well or not. And it's a gamble. You know, you could end up with some really, really crappy water, and we'll be discussing that in a couple of different slides as we look at it. So that water could be anything from calcium buildup, sulfur, iron bacteria, anything that is growing in this water or has been absorbed by this water is going to be in our geothermal units. And that's why it's so important that we are testing the water that we're using before we send it through these geothermal units. I mean, if you have horrible groundwater where you live, the best thing that you could probably do is to put a closed loop system in, charge it with some nice methanol or antifreeze solution, and just let her run. Because even if you have a well that you could get free water from, what's the point if you're going to be clogging up everything inside of these geothermal units? Another problem that we could run into with an open loop type of system is erosion. So any particles that are in the actual water itself, and we're talking sand, silica, rocks, they could end up being pumped up into this and then actually eating away at the copper and causing all kinds of problems for us in our geothermal types of units. And then we have incrustation, which is just basically a iron bacteria that once it gets in there, it basically starts to grow iron. We have this problem here in Lima, Ohio, in a couple of different areas. We can use an inhibitor that would clean it out. But I mean, who wants to sit there and continuously maintenance their geothermal? Nobody. So just watch the type of, if you're going to be doing this, just watch the type of water conditions that you get. You might want to suggest to the homeowner, maybe we shouldn't use your water. Maybe we should go with a closed loop. So on our systems, when we look at them, as far as our closed loop systems or earth coupled ground loop heat pump systems, we're always going to size these guys for the cooling load. And this is true of every geothermal. Now, with the invention of the inverter compressor, we're going to see some changes within the geothermal world and also within the heat pump world. We're going to be going to a more computer controlled piece of equipment that's going to be capable of ramping up and ramping down its capacities. So therefore, we could put a bigger heat pump in and then let it just ramp itself back to the appropriate cooling level. And then when it got really cold outside, well, then this thing can ramp up and give us even more heating capacity that was not available to us in a single and two stage types of units. So a lot of things that can go into this to make these guys more efficient. There are plastic loops that are running out into the ground. We got polyethylene piping, I forget the abbreviations. We'll see them here in a little bit, but high density, there it is, high density polyethylene piping. And it's different than your well piping that you're going to be running in the ground. So don't go to Lowe's and buy well piping and stuff in the ground. This is specific thickness of pipe to withstand the ground pressure and also little objects that might get to it and will eat through the plastic itself. So our closed loop system can either be horizontal or vertical, completely sealed, and it's completely pressurized. So we don't have to worry about water problems as far as incrustation, erosion, or water quality problems with it. And then the solution is circulated over and over and over again in that ground loop system that's out there. Small yard? No problem. We'll go vertical. We'll take these lines down deep into the ground and then we'll pump that heat out of it that way. It's just an installation practice. We can put these guys in the city. We can put these guys out into the country as well. So our vertical loop is no different than the horizontal loop, except for we're going deeper. And we're going to need a drilling rig to do this. After we get these pipes drilled, there's a couple of things that we need to do to the system itself, and we'll talk about that in a little bit. So the actual trench running out to the wells, we're going to have about 18 inches to 5 feet below the surface, depending on the location that you are in the United States. We'll have to put a foil back warning tape along the entire line because we don't want excavators to come through and dig up if we have a septic problem or we have a sewer problem and hit one of these geothermal lines. Now you're talking about calling out the geothermal company to take care of all this stuff. And our depth of our wells are somewhere around 150 to 450 feet in depth. 200 feet to 400 feet of piping per ton of refrigeration when you're looking at it. So you got a 2-ton unit, you're going to have 400 to 800 feet of piping. 3-ton, you're going to have 600 to 1200 feet of piping on it. So just some of the things to consider when you're installing one of these closed loop systems. So different configurations of wells as well. Okay, so we're going to go down vertically into the earth. We can do a large pit, a large well where we could run 2 separate pipes down the same hole, or we're going to run one, and that's going to be more of your traditional install. It's just one vertical well. Or we can go shallower wells, depending on what we're running into when we start drilling these particular wells. So we could use two loops that are shallow instead of really deep loops in there. And kind of think of this, that each we're gonna have about what they say 200 to 400 feet per ton of refrigeration, but one well per ton of refrigeration. So if you had a 4-ton, well, you're gonna have to dig four wells for that. It is a dirty job. So our closed loop systems, when we look at them, we're going to bring in drilling rigs, and these drilling rigs are going to either pump this dirt out that they're digging onto the ground or put it into a little container and make it go away for us. But you're going to need a drilling rig to do this, and this is why it's very specific type of work that not many HVAC contractors get into. We call individuals to work on those. So our vertical type system, we're going to have this U-bend in our piping, and it's going to be attached to a long spool, and we're going to take it, we're going to shove it straight down into the earth. We'll probably shove another pipe down there with it, and the whole purpose of the pipe that we're shoving with this geothermal pipe is that we can fill this well with a clay that is referred to as bentonite clay. And its whole purpose is to give the pipe flexibility, but also to seal the aquifers between the different points where we drilled down through. Here's an individual. He's going to be shoving that pipe down into there. Next slide is going to show us the filling material that they're going to be putting in it. So they got the well casing in there. They're going to dump that the piping down in there, and they're going to stick this tube down in there with a mixing device, and it's going to inject that bentonite grout into the actual well to seal it up, give it flexibility, and give it excellent thermal conductivity. So vertical loops, we need the bentonite grout. If you guys are a plumber, we use bentonite grout to seal up wells that are abandoned on our property. So the vertical U-bend, this is our rough end that we're seeing here. 3 different wells. There's one, and then there's one. We're going to take the geothermal unit. We might have one back there too. We're going to take the geothermal unit and we're going to trench in all of these different wells, and underneath the ground is where we're going to make our connections or our fusion joints for these wells. So couple of different rules and regulations that we have for our geothermal. 50 feet from a house or any drinking water. These are where we need to put our wells. 75 feet from public water, 25 feet from on-site wastewater. We don't want to contaminate our groundwater. Then we're going to have all kinds of environmental and issues, and we might get sued. You don't want that. 10 feet from a buried water line, service, or sewer line, 10 feet from property boundary. Some of the things that we look at when we're installing those loops out there. So a closed loop horizontal system, depending on where you're living, either in the south or in the north, you're going to be dealing with either 5 to 6 feet down on these. So, and I'll talk about that a little bit. 5 feet down for our northern states, 6 feet down for our southern states. Just the warmth that happens on our ground in our southern states. They want to go deeper to get that cool ground that's out there. So 2 feet apart, and then at least 3 to 500 feet of piping per ton, depending on soil type. So we look at our closed loop, 3 to 5 feet from the northern, 4 to 6 feet for the southern. Here's a trench, and this trench is just a depiction of what we're going to be doing with those well pipes. We're going to take one well pipe and stick it all the way to the bottom on a horizontal application. 2 feet above that, we're going to bring the return pipe back. And there might be a soaker line if you live in a really dry environment, because those the more moisture that's in the ground, the better it is for heat transfer, because that moisture is going to wick right up against that high density polyethylene pipe and going to allow it to transfer heat really well. And if we have an arid climate, we might have a soaker line right along with it. So just the different applications of the different trenching mechanisms that we have out there. We have backhoes, we have bulldozers, we have ditch witches that we could use to install these lines if we wanted to. So the average depth of our pipes is somewhere around 4 feet. So, but that's okay. I mean, like I said, it depends on the soil type, area that you're in, northern or southern states and stuff like that. But average 4 pipe to the center of it. Then we're going to start, if we want a singular trench, we can bring the return back and make it 2 feet apart, and it will be perfectly fine for our horizontal applications, just like this one here, where the backhoe is dug and we put the pipe 2 feet apart. We can also do a singular and put the pipe on the bottom and come up 2 feet and put another pipe in there. We can make it big enough to where we're putting them on the bottom and halfway up. These particular trenching that we're seeing, we can do a slinky type of configuration that's in the ground. Remember, this is a water loop. We're running the antifreeze solution or water solution through the ground, not the refrigerant itself. So more of the type of installation it is. Yes, it is a dirty job. Yes, it is a hard job without the machinery that's going to be there. So you're going to get muddy and you're going to get messy. So if you want to get into this type of work, all the power to you, man. Go for it. We're going to have to impact or embed these pipes with a nice silty, clayey type of material that's going to transfer heat really well, and also is going to be free of any type of debris that would cause the piping situation to get a hole in it from a stone or a piece of metal or anything like that. So just different applications. You can see the embedment that they put down on this one, which is a lot different than the clay or the dirt that's sitting on it. So you can see the pipe on the bottom, and then they came up 2 feet and they stapled that guy to the side. Just more applications, more things to see here. So we have header loops that are running down into these pits down in here, and after we do that, then we'll branch them off into different circuits that are running for the geothermal type of system. There's another header there. Horizontal directional boring. We can do that as well. It costs a little bit more, but At least your yard's not all dug up. We're just digging up a couple of different sections of your house and stuff. We can take this, missed that one. We can take this horizontal directional boring and we can take them under ponds, underneath the house and up into the house. There's a lot of things that we can do with this tool. And we're talking, millions of dollars for this piece of equipment that's sitting there. So if you got the money, you can do it. So we're talking different configurations of piping that we'll see on horizontal applications. Here's an outbound line and an inbound line. We refer to this as the reverse return header design. So one type, we can do a series type of system where we're coming in and going down into the well or down, running it all the way out without dividing it up into a bunch of different runs. And it's just one singular pipe that's flowing out and flowing back. Or we could have multiple pipes in a parallel application. So I would think that this would be the better one of the two that we just looked at, but um, to each his own, I guess. I like this one though. And then just the reducing L-type header, where as we take off certain runs, we're going to reduce that piping down so that the pressure remains the same throughout the entire system. Hey, much like airflow, right? Much like it. Just another example of that reducing down type of piping for 15-ton of cooling that's out there. I think this is more of a commercial application, obviously. And here we go again. So this is what it looks like in the ground. Just a mess of wires. Remember, you guys can pause this video if you want to take a look at it more. Look at, did I say wires? Just a mess of piping down in there. So that piping is sitting there, and then we're going to come off there and go different directions and then tie it back into the other line that's sitting there. So we'll come off, let's say we come off this one, it goes out, then it comes back and goes down through that one. Slinky type systems, guys. Wish I would have got that off of there, but I didn't. Can't be too many of those things left. Now here's your slinky. Now these things come pre-made, and what we'll do is we'll grab a hold of them and we'll slinky them out into a pit or a pond. Your choice. We can run these in ponds as well. Ponds just have surface area on the bottom side of them that we don't have to really worry about those digging out a big area. We can just use the pond to do it. More slinky. Here's some more slinky. Okay. And then pond. We can use ponds, and there's different types of apparatuses that we can put together for the loop that's running into the pond. We're not using the pond water. That's filthy and disgusting. Your geothermal wouldn't like that after about a week. So don't use the pond water, but run water through the loops out into the pond. Here's our trenchers as we're trenching the ground. You got a lot of farmland, you got a lot of time. Now you can do this yourself. Okay, concrete slab, directional boring, or we're going to run that pipe up and through. And look at this, we're going to put fern cones. And what that's going to create, protect us from is groundwater coming into the pipe and then up into the basement or crawl space. Here's a couple of them that they've drilled through the hole in the foundation. If you're going to do that, well, either you have it put in at the beginning of the concrete wall, or you're going to be putting that in and putting some hydraulic cement up against that fitting, and then PVC comes out. Then you're going to put a fern co. It's just a rubber boot that we're going to go onto the plastic and onto the high density polyethylene piping to keep groundwater from getting into the house. We're going to fuse all these pipes together. And the way we do that is we heat them up, melt them, and then snap them together for however many seconds that it's telling us. And it's different for the sizing of pipe that's out there. And yes, you need to be certified to actually be able to do that type of work. So on your install, just make sure that you're keeping the pipe clean. Don't get anything into the pipe. Otherwise, I mean, the flush cart might get it out, but you don't want to take chances. So make sure it's clean. And then pressurize it to make sure you don't have a leak, because that would really stink to dig up the yard to find your leak. So backfilling with the correct material as well. So here we go. Here's my flow center. I already went through a flow center pretty extensively with the other slides. So here's your three-way valves. These are where we're going to be hooking up our flush cart to be able to flush out the geothermal or the ground loop, or both at the same time, depending on how that three-way valve is positioned. Here's a flush cart. We're going to use it for pressure testing. We're going to use it to get all of the dirt, air out of the system. And then we're going to also use the flush cart to add our antifreeze solution to it. So a couple of different solutions. We have ethanol, methanol, and then a food grade polyethyl propylene glycol, which is what they find in your little vapes. So don't vape; you'll basically sucking in poison. So there you go. There's a geothermal install and different things. A couple of things to remember. Uh, the length of pipe that you need, how many per ton would be really good. The flow center would be good. Um, and the different configurations that we look at: groundwater heat pump, ground source heat pump, groundwater heat pump, closed loop heat pump, or direct exchange.